Thank you for being here. Thank you for the organizer to invite me. I learn a lot already. We just started. So, and I love to come to this conference where of course, I love to teach and to share what I know, but I actually walk away with more information and with more knowledge that I came. So I hope you're ready to learn a thing or two about service mesh. Who knows what service mesh is? 1, 2, 3, 4. Okay, good. I mean, I'll refresh a bit of information and then show you why I think service mesh is great for platform engineering. That's me. I live in Amsterdam. I run the Dutch Kubernetes meetup, by the way. So I'm a CNCF ambassador. If you ever come to Amsterdam, let me know, because we can have a nice beer, or we can organize a meetup. We do have meetups all the time. We organize conferences. I'm a platform advocate at Solo.io, not a developer advocate or DevRel, platform advocate, because we really are into platforms and helping people and companies, organizations building platforms, and I'll explain why in a bit. So let's get on the same page, right? So let's get some definition. I know you may have heard about these a lot, but this is my definition. Of course, it's something that you may or may not disagree, and I will be very happy to discuss. So, as I said, I'm very involved in the community, especially the CNCF community, the Cloud Native Computing Foundation, which has a bunch of sub-communities or subgroups. One of these is the CNCF Platforms Working Group. They recently published a paper about platform engineering. What does it mean to do platform engineering with cloud native or within the cloud native context? It's a very informative white paper. I suggest you go and read it. Some of these ideas are inspiring me, of course, and I did contribute for a little bit. For me, the one defining feature of platforms or platform engineering is the self-service, right? So, and that's my opinion. You may have found some other characteristics, like I say, self-service. We all love, of course, the cloud. Cloud as a business model, right? So, but cloud is also this self-service model of consuming resources, and a platform engineering aims to do this, right? So to provide you with self-service, which is the best thing ever. We can go to sleep, we can do some other things while our users are happy and consuming resources and building stuff on top of our platform. It's integrated, as in is one place to find everything, one place to consume in a self-serving way all the tools, all the best practices that you embed in the platform. You should treat it as a product. We talk about this. Michael, of course, made a mention of it. It's great to. You should not think of one other project in your organization, but really something you have to love, like you love a product, and you provide it as a service to your stakeholders, in this case your developers, and it's all about developer experience, right? So giving building something that people will love to use and will come to you and say and thank you for building such a product for them. Bring values, which is one of the most important. I know you may have already heard this. Reduce cognitive load. What is cognitive load? It's this toil that goes in your head when you are struggling using something that is really difficult to use, or some systems that are convoluted or very hard to understand. So reducing that frees up resources in developers' heads and minds to focus on more value-added activities, like sleep or going to take care of their family, right? So consistent delivery of value, improve sharing and reusing knowledge. This for me is quite important. Like all the best practices you already have, why don't you embed them in your platform? Why don't you make them the default, right? So make them like they are easy to consume. Like it's always like this part of DevOps culture, right? So make the right thing the default, right? Make the right thing just the easiest thing to do, and then people will just do the right thing because it's just they find it so easy and so natural to do. And you centralize, and this is the crux of this talk, is centralize and automate security and observability. So we're going to talk about this. Of course, all brings to developer productivity, which sure it does make for a good business case. Our employers love this because, of course, they get more for their bucks. They can squeeze more out of the developers, but it's also good for us, right? So if we are more productive, we have probably more time for ourselves and to take care of our mental health and general health. This being SRE days, of course, I need to mention what is, for me, site reliability engineering. I remember when the book came out. Indeed, it's a big book, and I confess I didn't finish it yet. But and of course, it's the book that describes how Google does it. Right? So you don't need to do like Google. You don't need to be Google to take the best lessons out of really anyone, and in particular the people and the people working at Google in SRE. But it's something that there's lessons in everything, right? So in particular, this book brings you the best lessons of SRE. So what is SRE for me is really a culture. Like DevOps is a culture. I mean, or the most defining trait of DevOps is not the tools, is not what metrics you choose. It's more like it is the culture that goes behind it. So culture is very vague thing to define, but again, for me, is a common set of values that a group of people in an organization, in a country, or at the book club, they share, right? So SRE as a culture needs to have something around it. So what are these set of values that SRE culture should? You may, of course, find your own, but some simple things are automation, right? So this comes from DevOps, right? That's why there's this idea of DevOps is dead, SRE is now the new black, the new DevOps. So we've been talking about this for a decade, right? So all things that brings automation are good. You should strive for more automation because you are more productive if you automate away manual tasks. Uptime, right? So this is of course, this is for Google is the best metrics, right? So they only sell or ads when the site is up. But for you, it can be something else, right? So it can be something that is not really related to uptime. So it's find your own metric to decide this is what we need to do, this is what we need to focus, this is the most important thing for us. Sharing, again, if you look at these are kind of the DevOps pillars, if you think about. So DevOps was built on this culture of sharing, of collaboration, and SRE, like Ricardo was saying, it's about like helping other people be better at their jobs, or helping other people. So SRE really is the embodiment of carry water, chop wood ideas, where you actually help people be better and mentor other teams, mentor other people to be great at what they do. And of course, like be always rigorous in applying. So this is the culture. Culture by itself is great. Of course, we share the ideas, the values, but of course now we dive deep into the tooling, right? So little story. Of course, cloud native applications been around for 7 years, of course. So it's not a new thing, but maybe it's something that still people struggle to understand. So this is the definition by the Cloud Native Computing Foundation, which is recognized authority of cloud native, which is this set of practices and tools to build resilient distributed applications. So, and there are few things that you cannot miss when you build a cloud native application, which is of course containers, just because containers are great at containerizing applications. Thinking in API, so having good understanding of the boundaries between the services, and of course, like building everything in microservices. So these are in the definition of CNCF is on GitHub, and in the definition of CNCF, there is also the mention of service meshes, and I'll introduce you in a moment. So if you are confused by the landscape, you're not alone. That's meant to be confusing, I think. It's meant to be just the state of the world with everything that is there. Landscape of CNCF.io, it's now is a joke or a meme. Everybody laugh when you see this. We don't really do anything with this because we know better than just be overwhelmed by a number of tools. But tools nonetheless are what our trade, right? So if building cloud native application, cloud native infrastructure is our trade, these are our hammer and tools that we use to build those. So these are important nonetheless. But so this is one thing that really stuck in my mind. So Kubernetes, if you know, is one of the most popular orchestrators out there. It's just a platform to build platforms. And interested in platform engineering, I also explore this, and I understand how, and I will explain in a moment, how service mesh is also a platform in itself. So what is service mesh, right? So, and in a moment we'll show you. So what is a mesh? Is really a topology, right? So a mesh is just a mathematical definition or geometrical definition of interconnected nodes, right? So it's just that. It's a way to connect nodes in a mesh way. That's it. So it's nothing. If you keep this in mind, then you understand how you apply these two networks and two microservices can make sense. So it's a way to prevent, or to think about. These are the famous 8 fallacies of distributed computing. Everybody falls more or less sooner or later for one of these. I did as well. Of course, when you build something, you don't account for this, and you assume. Assumption is the mother of all mistakes. So one of these will eventually bite you, and we want to avoid this. So how to make a network reliable out of unreliable components, and that's where we come in with service mesh. So we all been there. Monoliths. Today we talk about how to break down monoliths. Of course, they work until they don't anymore, and then of course, like you may think it's a hype, or we should not break monoliths too much, or but this is what happened, right? So this is what is today the landscape, the state of the art. You're gonna build something. You probably want to start in a monolith, but eventually you will find yourself dealing with cloud native applications in microservices, right? Decompose into their components, and then the complexity is exploding, right? So it goes quadratically with the number of microservices you are decomposing your monolith into. So, and then of course, at least Kubernetes will save the day with orchestration, right? So Kubernetes is a very opinionated platform to manage, run, take care, restart, and deploy these containers, these microservice applications, but it still leaves a lot to be desired, right? So Kubernetes is just a platform, right? So there is good stuff in there, stuff that will help your daily life in the infrastructure or platform engineer life, but it's still not enough, right? So we all love Kubernetes. Of course we use it everywhere, but it just gets you to some point, and then the rest is up to you. So it's got a lot of batteries included, except the networking batteries, and that's where service mesh comes in. It came out as a complement to container platforms, like an add-on, something that you can use to get a better overview of your microservices, and then it evolved into what is today a security and networking platform. Keep this in mind. So you want to tame this, you want to have some understanding of what's going in there. there is not many ways to do it. What you have to control is the networking, is the connectivity between the microservices. You don't need to be Netflix or Uber to find this daunting and needed of some tooling to manage, but it is what we find that we need to take care of. So, and what's important, like Ricardo was saying, observability is the key, right? So to get a good picture of this is to understand what's going on in between the microservices. Of course, you need to understand what goes on inside the application. Definitely you should instrument your application with OpenTelemetry, all sort of SDKs for that. But what goes on in between the microservices, that's the crucial part, the real important and interesting information to understand and to control. So not only you want to see the traffic, visualize the traffic between the microservices, but you want to control it. You want to make sure that service can talk to the service that they are supposed to and not anybody else. And so you want to secure that communication between the services. So that's very clear. So what we need is a programmable framework to make us able to observe, secure, and control and connect these microservices. And that's exactly what a service mesh is. So not only those perks, those basic functions, but also you can get out of the box service discovery and load balancing and traffic control. So really can granularly control your traffic in and out of your microservices. Who doesn't want that? So that spun up a whole ecosystem of tools, of course. Everybody's an opinion, which tool is best or what approach is best. There are dozens of service mesh out there. Pick your own. But I'm here to talk about one of them, which is Istio, which is probably one of the it's probably the oldest, at least one of the very first to really be useful, to reach like maturity. And it's an open source project, of course. Is a CNCF project, so it's been recently donated. It started as their own, the Istio Foundation, so to say, or the Istio there was a different foundation managing Istio, but then it was donated to CNCF, and now it's part of CNCF. So it's like Kubernetes and Prometheus and 170 other projects, part of this big family of open source projects. They are part of the Cloud Native Computing Foundation, and it's a service mesh. It is a tool that can help you connect, secure, control, and observe your microservice infrastructure. That's the history. So launched in 2017, which is quite a long time ago. Eventually, Envoy was adopted. Envoy is this very efficient, very programmable proxy, born and lived, also a CNCF project. Thousands of production customers, eventually donated to CNCF, and recently, literally like last month, now graduated by CNCF, which means it is indeed like production ready. It is one of the most safe and featureful service mesh. So that's why I'm talking about it, because my company and my interests are in Istio. So I'm part of the community. I'm part of my company has a big interest in Istio, of course, because we have a product around it, but also because we believe it's one of the best service mesh out there. Very simple. If you don't know service mesh, this is quite a common pattern in service mesh. It's the sidecar pattern, right? So how do you achieve this level of control and observability in a service mesh? You have to get close to the application. You cannot observe something from far away. You have to go in, really, and embed a proxy next to your pods, inside your pods, literally next to your application, right? So by doing that, you are now in control of all the traffic that goes in and out of your application. In this case, of course, if you're in Kubernetes, this is trivial. You inject a new container in your pod. You make sure that all the traffic by some IP tables, magic, eBPF redirection goes through the proxy instead of right out of the application. Then you can look at all the requests, look at all the TCP connection, all the HTTP connection. You can even automatically inject certificates into each proxy and let it connect to each other through mutual TLS. So very simple. There is a control plane, of course, managing these proxies, and the proxies do the magic by talking to each other and securing the traffic, spitting out all the Prometheus metrics you need, all applying the policies that you want, right? So if you program a proxy not to accept requests from specific endpoints or host names or IPs, that will be in the NIST in the Zero Trust framework. We call it policy enforcement points, where you can enforce a policy and what's better than just right next to the application. So of course you can also manage the ingress and the egress out of your cluster, because you can use Envoy for that. This is what we do, of course, in Solo, but it's a possibility to also extend the mesh beyond your cluster into other clusters, virtual machines, whatever you feel like. So not only that, of course, you can get all sort of features out of that just by using this model of service mesh in your cluster. So that's what we do. Of course, it's something that we really know and we love, and we think it's crucial to a platform that worth its name to have a service mesh, to have this level of observability and control over what you're deploying in your infrastructure. This is Kiali, one of the dashboards for Istio, so it shows you exactly what's going on. It can show you exactly what requests are being made, and if the traffic between your endpoints, your services are secure. Zero Trust, I'm not going to talk about it, but it's definitely something we can talk about. We have a new way of deploying Istio, of course. If you want to know more, we have all sorts of workshops and labs you can do. So there's not only the sidecar model possible, there's also the proxy per node model. So this is a way to reduce cost and waste in your infrastructure. Of course, running all these proxies can be expensive, but we are innovating in the community, and we are introducing this new way of running your service mesh with just less moving parts, less proxies, and better efficiency. So same thing is exactly the same thing. So you get this exactly the same APIs, the same features of Istio. It's just a new way of deploying. So, and the proxy is just, you have way less proxies than in the old sidecar model. So, but all the features are there, all the advantages are there, all the improvements are there. So let's tie it all together. I don't know about the time, but I think we are about 3 minutes. Great. So it starts all the way down. So platform engineering can implement or should implement Istio or service mesh because they want to adopt SRE practice. And of course, SREs should leverage a service mesh for observability, security, and so on and so forth. So this is the core of the idea, something that I would like to, if you want to know more, of course, if you want to use service mesh in your infrastructure, on your platforms, I think it's a good place to start. You can start with Istio, you can start with other service mesh, of course, but please do think about adopting a service mesh. Don't leave a service mesh alone, just adopt it. This is what I think is something like the well-architected internal development platform. You can run it anywhere, of course, but you do need things like the single source of truth, where all the definition of your application live, secret store, a place to store state, of course. Things like GitOps and Argo and Flux, they greatly help you build this developer platform because they automate away most of the manual, kubectl apply kind of stuff. And of course, you need a portal, right? So, and what best portal out there, of course, everybody knows Backstage. We do have an integration with Backstage, so using Service Mesh and API Gateway, exposing your your API to the world through a Backstage integration that we have in our Glue portal. Very quickly, I can show you, of course. So this is demo.glueplatform.com. We have this is our Backstage integration. It's really something I can show you quickly. Well, should be logged in already. Okay, but at least here I am. No, I'm not. Okay, come on. Okay, Okta doesn't love me anymore. Okay, so my Okta login probably doesn't work, but trust me, this is our portal to showcase what happens when you integrate. This is our API portal, and you can see all the APIs listed here, and they're all part of course, also our Backstage integration. And okay, it's too late anyway. So the idea is that you can build a resilient and observable platform using Service Mesh, of course, and all these other tools. We all love tools. And then the takeaway is that this Service Mesh really ties my platform together. And some tips from me, of course. Everybody loves to give away some tips or my opinion. Stay humble, right? So start from scratch. Just use the very basic features of Service Mesh. Things like mutual TLS. They come out of the box. You don't really need to think about it. You don't need to do chaos engineering with Service Mesh. You can, of course, or progressive delivery. You got the tools that Service Mesh gives you the option, but stay low for in the first phase of develop or deploying or delivering a platform. You grab the low-hanging fruit first, of course. Get security and observability from the start. Yes, you can roll your own and do all sorts of your own things, not invented here syndrome, but why not using an off-the-shelf open source project like a Service Mesh and Istio? Think about who is using it and who is gonna pay the bill eventually. Plan for. Don't be surprised if these things really takes hold quickly, and think about the people first. And use a Service Mesh, please. And if you don't know how to choose Istio. You won't be wrong. Eric, great to meet. I haven't met him yet, but I saw his talk. We have a webinar together with Solo coming up, and friend of mine, Sala Boy, is not here, Maurizio Salatino, but he has a book on platform engineering. I promise I would give him a shout, and some references, and the slides will be shared soon. Thank you very much.
Thank you. Okay. Let's start here.
Really nice presentation. Thanks a lot. We have implemented Istio Service Mesh in our company, and one of the challenge which we recently faced was using Istio CNI along with HashiCorp Vault, to get the secrets, where Istio CNI had created some problems. What is your opinion on the CNI, of Istio, or should we then, is there a workaround which you have, worked on?
So I don't know why they conflict. So Istio CNI is a CNI is container networking interface, just for everybody to get on the same page. So it's a standard of APIs from Kubernetes for a network plugin to do the plumbing whenever a new pod comes up, right? So it's it's just a standard, really. So Istio CNI is not actually a CNI. It doesn't really replace your own CNI. So Istio CNI should just help with the we're setting up the networking between the containers that are part of the mesh. So I don't know, but I'll be happy to help you out. Yeah.
Well, thank you. Thanks a lot.
And another one here.
Great talk, by the way. Thank you. I've got two questions, if you don't mind. First off is I've heard someone actually mentioning that one of the challenges of service mesh is certificate management. Is that really the case, or is there some sort of tool that kind of alleviates this process?
Yes, it is non-trivial, as in, so service mesh, of course, like a project like Istio and more, they tend to favor the ease of use, right? So the first time experience. So when you deploy Istio, you get a CA out of the box, but that's definitely not enough for a production deployment. So integrating an external CA is what is indeed like a pretty important task when you go in production with service mesh. So we have integration with a lot of different CAs from AWS and Azure, and definitely Cert Manager as well. We integrate with the project to provide certificates and CAs to Istio. But definitely Istio doesn't make, or service mesh should not and does not, Istio does not make an opinion how you should run your PKI. So we tend to be to integrate with external. And also now, as you may know, there's the whole point of SPIFE and SPIRE. So SPIFE is a CNCF project. It's called Secure Production Identities for the rest of us, framework for the rest of us, for everyone. SPIFE, Secure Production Identity Framework for everybody, which provides workload identities to workloads, right? So, and then Istio leverage that to gain a knowledge of who the workload is, what it's supposed to do. So that this is like playing nice with other projects like SPIFE, Cert Manager, and other CAs.
Right, thank you. And just second one very quickly. What are some of the things that you should look out for when migrating from microservices to service mesh? Are there any sort of gotchas along the way, or is it just a matter of installing the mesh control plane and flipping a switch on the containers?
Definitely not. So one thing really confused people, right? So now your application has a little sidecar next to it, so it's not the same troubleshooting that you are used to. So if you're looking for just simple troubleshooting, just to get trace route or get the request out of the application, you will be confused by the presence of this extra container which runs Envoy. And so now you need to learn a bit of how to debug Envoy. So for me, it was a bit of a learning curve. But yes, once you get that, you get all the advantages, and you can also troubleshoot your application efficiently.